All right, so 12.1 deals with some basic anatomy type questions. We will go through part 1 and part 2 today. For part 1 and part 2, we start with first knowing what tangent to the circle is. So hopefully you understand that if we have a circle, a line that touches the circle in one spot is called a line that is tangent to the circle. Okay. So the line itself is tangent to the circle. Hopefully you understand what the point of tangency then would be. Correct. The point of tangency is where the line specifically touches the circle. So you have a line that is tangent to the circle, and then you have the point of tangency is where it actually touches. Okay. You also have to remember that you still have things called radius, okay, a diameter, which is twice of that. You also have to know what this is called. Hopefully you remember what that is called. That is called a central angle. And you also have to remember that your central angle and your arcs will be the same measurement. Okay, it's a lot of information in a short amount of time. Okay, so you have your point of tangency, you have your tangent to the circle. You still have to keep these things in mind when they give them to you in the description or the directions. They're not always going to give you a picture, and they're going to expect you to recreate a picture. This whole chapter deals with lines of tangencies in a circle, and it has to do with angles that are in, on, and out of a circle. Now notice I said in, on, and out of a circle, not inside. We don't use the word inside because a circle doesn't have sides. So it's in, on, or out of the circle. Okay, in, on, or out of the circle. Hopefully you understand that the central angle happens to be in the circle. We're going to learn about a lot of different angles. Angles that are in, angles that are on, and angles that are out. So this line is called a tangent. Okay, now we get into the rules. These are the things that you have to study. Okay? So if you have a circle and you have a line that is tangent to that circle. Okay? So you have a line and a circle and a line that's tangent. The radius will always, anybody want to take a guess? What do you think it'll do? It'll form a right angle. You are 100% correct. Yep. So that means in most of your pictures, this is what you're going to have to add because it won't be in your original picture. Notice, see it's a radius, and when it touches a line of tangency, it will always form a right angle. That's one of the rules. It will always form a right angle when the radius touches a tangent line. Well, what if the radius touches a non-tangent line? Then there's no rule. It has to touch a tangent line, which means you're going to have to put that measurement there. You have to put the right angle mark. Well, why would that be important? Well, if I drew another line here, this would be a right triangle. Yay! And then we would understand, oh, I can use right triangle work to find the measures of the lengths. Yes, it has not gone away, nor will it. Right triangle work is here to stay. And we've learned it. You're supposed to have known it. 30, 60, 90, 45, 45, 90, sine, cosine, and tangent, and 8 squared plus b squared equals c squared. All of those things you will still use. You'll use all of it in chapter 12. That's why we've been working it all along. If you thought you were going, oh man, I'm glad we're done with 11. Hopefully we learn something different. Not really. Different uses of the same stuff. Okay? So understanding that you have to add the right angle marks. So what kind of things can prevail? Or what kind of things will you see? Well, they might do something like this. Let's add to this picture. I'm going to put another line of tangency. Okay, and we'll draw another radius. What's going to happen here? Yep, I'd have to add another right angle. Now, is that going to be a triangle? No. It's not going to be a triangle. Why is it not going to be a triangle? Because it has two right angles, which means the third angle would have to be what number if it was going to be a triangle? It would have to be 0, right? Is that possible? No. Which means there's a measurement here. I just didn't put it in. The measurement here is 179. Notice that's pretty close to a straight line, right? But it's not. So I have 90, 179, and 90. Does anyone want to tell me or take a guess of what they think this last angle will be? It's not a triangle, so that means it has to have how many sides? 4. Anybody want to tell me what that last angle measurement might be? What do you think all the angles inside this shape have to add up to? 360. Why would they add up to 360? Because it has 4 sides. Anything with 4 sides adds up to 360. So, who wants to tell me what that last angle measurement would be? 1 degree. Yep. Yay. Good job. 1 degree. So you're going to use that perpendicular rule to find the measure of angles for 3-sided or 4-sided shapes. Could be 5-sided shapes, could be 6-sided shapes. But that's what we're using all the time. Why? Because that's what we're using all the time. Okay? We should always be trying to find right triangles so that we can do right triangle work, or use that information to be able to find the measurements of other angles. So we're going to do another one. Here's a circle. And this time I'm going to give you a diameter. Okay. I'm going to give you a line that's tangent. And we're going to call it, this is D, this is O, this is E. All right? And I will give you this measurement right here of 18 degrees. And I want to know what is the measure of angle E. I'll give you a second. Pause the video, and then we'll come up with the answer. All right, welcome back. Hopefully you went ahead and you added the right angle mark here. So now you have 90 plus 18 plus x equals what magic number? 180. Excellent. Correct, because that is a triangle. Remember, triangles add up to 180. If it had 4 sides, then it would add up to 360. We knew this was 4-sided because we couldn't have two 90s. Yes, and angle E is 72 degrees. All right, last but not least would be something of a realistic type question. Let's say you have the planet Earth, and you have the Eiffel Tower. And the Eiffel Tower stands 447 feet. 447 meters will be realistic. So see, there's the planet and the tower standing on top of it. And I tell you that to get to the center of the Earth is 6,400 kilometers. So that means if I started digging, it would be 6,400 kilometers, which means that is actually a what? What would the 6,400 kilometers be? Yes, correct. It would be the radius. Now, if I were to draw a line of tangency with that radius, what would I form? I would form a right angle. And notice that that line of tangency also is to the top of the tower. So basically what I'm saying is if I look at stand at the top of the tower and look at the horizon, that means the area which you can see, where the horizon and the radius meet would be a right angle. And then, what do I know about this measurement? What else is that going to also be? It's going to be 6,400 as well. Was it in the original picture? Well, no, it wasn't. I added it. Why did I add it? So I could make a... What shape did I make? I made a triangle. Because there's things I know about the triangle, like Pythagorean theorem. So if I wanted to know how long this side was here, well, I could do a squared plus b squared equals c squared. The problem is going to be 6,400 is going to be my a squared, b squared, or c squared. We'll just say a, okay? What is this measurement going to be? And how did you get 6,847? You have to add the two. Now, is that going to be the B side or the C side? Wrong. It's going to be the C side, because the C side is always across from the right angle mark. Yes, excellent. So hopefully you understand why I put the right angle mark in there, because it tells me which side is my C side. So this would be 6,847. It was excellent. You were supposed to add those, but this is the right angle mark. Can you go by what the picture looks like? No. Guess what people's biggest mistake is? They look at it and go, well, that's not what the picture looks like. That's what the right angle mark tells me, is this is my hypotenuse. And then this would be the side I'm looking for. B squared, x squared, whatever you want to call it. I use my lovely Pythagoras theorem. And as I do my lovely Pythagorean theorem, I am going to get what'd you get? What'd you get? Should have gotten 2,000. Right, 2,433. Now, if you wanted to, you could type it into your calculator all at one time, because when you move this over, it would be the square root of 6,847 squared minus 6,400 squared. That's why you have this calculator. You literally do it like this. The square root of 6,847 squared minus 64. 100 squared. You can put the whole thing underneath the radical. You can do it all on your paper, the algebra, and then turn around and do it on your calculator like that, and bam, gives you the answer. You don't have to do it piece by piece. So if you know how to do the algebra, you do the algebra first. So how far is it from the top of the Eiffel Tower to the horizon? It would be 2,433 meters. All right, so the a squared plus b squared equals c squared is really important. I will tell you that you have to pay attention to where the numbers are located in your pictures. Numbers they always put are in the middle of the segment. So that 12 tells me that this line segment would be 12. If they put a number here, what segment is that 7 representing? Hopefully you know it's from here just to here, that's 7. Why? Because they put the number in the middle of the segment. They do that all the time. If they wanted the 7 to represent the entire thing, they would put the number 7 here. Some of you are having a hard time reading some of the pictures, so you have to be very careful where they put numbers, just like they do with letters. Okay, but again, you're still doing the Pythagorean theorem a bunch of times. A squared b squared equals c squared. All right, good luck on 795. That is part 1. I'm going to move on to part 2. Part 2 just uses more rules dealing with the radius. Okay, please remember you're doing problems 1 through 14. Actually, 1 through 15. Okay. All right, so part 2 has to deal with more rules. You don't have to pay attention to me. Remember, these are all put on Portal as well. They'll be on YouTube tonight. Okay, so what are some more rules of tangent line? Okay. So when we start talking about tangent lines, you have to know that here is the next rule. If you have two lines that are tangent to the same circle, then their distances to that point out of the circle is the same. So if these two lines are tangent, that means this distance is the same. So hopefully you remember our inscribed circles where we had different shapes. So like if you were to see something like that, you would see you have the circle inscribed and you'd have 4 lines of tangency. That tells me that I can add to this picture the congruency marks. So this measurement and this measurement are the same. This measurement and this measurement are the same. This measurement and this measurement are the same. And this measurement and this measurement are the same. Remember, they're the pieces going to the circle. Okay? Just the piece. So that means each corner ends up being equidistant to the circle. Now, it doesn't matter what the shape is. It could be a triangle, it could be a square, it could be a hexagon, it could be a heptagon. That concept still remains. So what do I tell people to do? Well, I tell people that the first step to doing this would be to make sure that you draw the circle, and then you put the measurements in that they give you, right? So let's say they give you, this is a picture, and this time we're dealing with a triangle. And let's say they give you this measurement here of 10. Okay? So, and they give you this measurement of 15, and they give you this measurement of 8. And they say, what is the perimeter? Well, now I have to put in all the other measurements. I automatically know that if this one's 10, I know this one's 10. I know if this one's 15, I know that this one's 15. And I know if this one's 8, then this one is 8. And then if I want to find the perimeter, I just add them up. So 10 and 10 is 20, 15 and 15 is 30, 20 plus 30, 8 and 8 is 16, plus 16, and my answer is 64. 6 units. Okay? So they can change the shape, but it's always around a circle. And the rule is that anytime you have a line, 2 lines of tangency meeting at the same point, they're equidistant. That is one of the first rules. It's actually the second rule of lines of tangency. All right, so then the next one would be what I like to call the bicycle problem. Okay, and this one is difficult only because when you look at these things, you're going to have a tendency of being confused because it's not something you're used to. So I call it the chain. All right. When you have a bike chain, hopefully you know that it's tangent on 2 different sides. Okay, now this picture always has a tendency of looking the same. The key to this is understanding that you're going to shift. You're going to slide things. So I'm going to use the paper to show you. You and I both know that if you drew a line from here to the tangent line, what does it do? It forms a 90-degree angle. Just like when I do it here, it forms a 90-degree angle. Okay? The problem is a lot of times they're going to ask for this distance. Now, it's going to be hard because right now you don't have what shape? You don't have a triangle. Okay? But watch what happens. These 2 lines are parallel. The distance from the middle and the tangent lines. Well, they're not parallel, but they're both straight. If I were to shift that center line down, I now make a right triangle. Well, how can I get this to shift this much? Well, if you look at the picture, you can see which radius disappears. It would be the smaller one. So how do we make something disappear that was there? What operation? Hopefully you know it would be subtraction. So in other words, you have to take the bigger radius and minus the smaller radius, and now you have right triangles, whereas you did not have right triangles before. Now the distance from here to here is still the same. I'll even show you with a pen. I'll put a mark there and a mark here. See that distance? When I shift it up, it's still going to remain the same. Okay? So if I want one side of the right triangle, so I will draw the right triangle. I'll just draw it upside down though. There's the right triangle. This side here is now the subtraction of the bigger radius from the smaller radius. Okay. This is the distance from center to center. And you notice that distance will always be the what? Correct. It will always be the hypotenuse. I can't spell center. Okay, this will always be the hypotenuse. Okay. So you can see when we shift that, now we have right triangle. We can do right triangle work. A squared, B squared, C squared with the different pieces. And that is part 2 of 12.1. So it's pretty easy. It's not too hard. Memorize some things. You're good to go. The key is making sure that you memorize. Many of you have a tendency of saying you're going to memorize and then not. So, alrighty. Thank you very much.